Okay, class, the next portion of this measurement chapter is all about our favorite density. And trust me, by the end of this, you are gonna love you some density. All right, density is a very awesome physical property. It is a ratio of the mass of an object to its volume, how dense something is, how much matter is going to be on the inside. So density is equal to mass over volume. Well, if you take the m over the v, you are going to love this analogy because the m and the v make a heart. Yay! So you can always remember mass over volume. All right, the units are grams per milliliter or grams per centimeter cubed. Okay, remember that 1 milliliter is the same thing as 1 cubic centimeter. Okay, so these two things, it just depends on if this is a 3D object or if it is going to be a liquid or use water displacement. These two things are the same. So if something like aluminum has a density of 2.70 grams per centimeters cubed, it's also 2.70 grams per milliliter. Both of those things are the same thing. Now, the um, density of objects is going to be really important in identifying the objects. We're going to do some labs in class with that as well. Okay, the big thing to remember is the density of water. So star circle, highlight that. The density of water is 1 gram per cubic centimeter. All right, so that's actually going to be at 25 degrees Celsius. The density of water changes a little bit with temperature. Okay, the colder it is, the less dense it's going to be, so much so that the density of ice is 0.92. So that is why in a glass, if you have ice cubes in it, um, the ice is going to float because it is less dense than your water. Okay, so water has a density of 1.0. Ice is about 0.92. So anything less dense than water is going to float in it. So cork, which is made out of the bark of a tree, gasoline, ethanol, all of those things are going to float. Okay, oil here is going to float because it is less dense. Now, the things that are more dense, like bones, lead, mercury, golden syrup, which is the same thing as like Caro, okay, they are going to sink because if water is 1.0, this stuff is going to be greater than, and this stuff is going to be less than that in density. All right, so go get your calculators. Make sure that you have that handy so that we can work through some density problems, and I can show you some common mix-ups that people have with them. All right, so whenever doing a problem, you always want to make sure you identify what's given, what's unknown, and what it is that you're actually solving for. All right, so here it says a copper penny has a mass of 3.1 grams. Don't forget units, they really help you out. And a volume of 0.35 centimeters cubed. What is the density of our copper? All right, so we are given a mass, M is for mass, of 3.1 grams, and we are given a volume of 0.35 centimeters cubed. And then the question word, we are looking for the density. So how do we solve these? With our density equation, and we love density. So all you have to do is plug in your 3.1 grams for your mass, and you plug in your 0.35 cubic centimeters as your volume, and get out your trusty calculator. If you don't have it, go get it. Push pause, come back. Hey, you're back. All right, and in your calculator, you simply put 3.1 divided by 0.35. And what do you get? You should get 8.9. This has two sig figs, this has two figs. My answer should have two sig figs. What are my units going to be? Well, grams divided by cubic centimeter. Nothing canceled out, so that is your answer. and it stays just as is. All right, so if you couldn't read any of my writing, here is the exact same thing typed out for you. We are given the mass of 3.1 grams, the volume of 0.35 grams. We're looking for density. We love ourselves some density. 3.1 divided by 0.37 is 8.9 grams per cubic centimeters. Now, second example. It says a sample of aluminum metal has a mass of 13.8 grams. Okay, so mass is 13.8 grams. The density of the sample is 2.70 grams per centimeter cubes. Calculate the volume now. All right, so we are given mass is 13.8 grams. The density is 2.70 grams per centimeters cubed. And our unknown now is going to be the volume. So how do I solve for this one? Well, I still use my density equation. But one of the big pitfalls that students have is solving for the denominator. So how do you get V by itself? Well, I'm going to teach you a little trick. All right, so over here, density is mass over volume. Now, in algebra, if you want to get a denominator by itself, you have to get it by itself. So you do that by multiplying both sides by V, and then you'll see that the volumes cancel out on the right-hand side. But now we have volume times density equals mass. So how do we get the V by itself? Well, it's currently being multiplied by D, so now we have to divide both sides by D. So what we get is density and density to cancel out, leaving V equals M over D. Okay, if you take a look at these two equations, what's different? Okay, the big difference is density and volume have traded places. So if you're ever looking to solve for a denominator, so it's something equals some sort of fraction, okay, if you want to solve for the denominator, just switch the thing that's by itself and the fraction. So volume is equal to the 13.8 grams over 2.70 grams per centimeters cubed. What you get is the grams and the grams cancel out, and you get 1 over 1 over centimeters cubed, the inverse of the inverse, which is the regular number. And in your calculator, you are going to put 13.8 divided by 2.7 equals, and we should get 5.11. All right, this has 3 sig figs, this has 3 sig figs, my answer has 3 sig figs. So to show you that all typed out nice and neat, okay, density equals mass over volume, and then you just trade where the V and the D are, so you can solve for volume, and then you can plug them in, and you get your 5.11 centimeters cubed. Now, when you compare densities to one another is when you take a look at the specific gravity of something. And this is usually more common with our liquids, all right? Or, I mean, it could be a comparison of a liquid and a solid, but the comparison of your density where you have a known reference substance, okay? And basically what you're doing is you're seeing whether it sinks or floats. So the specific gravity, you have the density of the substance that is above it and the density of the reference. And the reference is usually that of water. It's cheap, it's easy, everybody has it. So the density is at 4 degrees Celsius up to 25 degrees Celsius is going to be 1. So it's something over 1. So a hydrometer is this special device that's used to measure specific gravity. So they basically get a hydrometer jar that contains the liquid, so it would be filled with water. and they would drop the substance into the middle of the water. So it breaks the surface tension, it won't just float on top. And then when it's here, it's either going to float or it's going to sink. It's not going to stay as the same. All right, so if you put lead in there, lead would sink down to the bottom. Lead has a density of 11.35 grams per centimeters cubed. But if it is something that is less dense, it will float up to the top. And this is used sometimes as a quick little reference test for diabetes. Diabetes is the inability to to make insulin to process body sugar. So sugar is a waste product, and since sugar is water soluble, it comes out in urine. So if they take some urine and they put it into water, if it's completely fine and soluble, it will mainly just kind of like dissolve. But if it starts to sink down to the bottom, it means that there's a lot of sugar in it. And that could be an indicator that you could have some diabetes. Then they can go through and they can measure your sugar and all that kind of stuff and hopefully get you the treatment you need. So that, my class, is our density and specific gravity.